Hello everyone, this is Saurabh Sharma. Let's begin our series of current affairs. And today in this session, we will be talking about the first thing is it is science and technology related topic, and it is about Chandrayaan 3 mission. Chandrayaan 3 mission, this mission has so much of information for our prelims perspective and many things about your interview area where questions can be asked from you. So the context is that India plans to execute the Chandrayaan 3 mission in August 2022, the concerned minister told the Lok Sabha recently. So this news has the relevance because it is going to be India's great achievement, because it is not a new mission. It is just a continuous mission of similar continuation, because our Chandrayaan 2 was not a success. It got crash landing while it was landing on the south pole of the moon, right? And this was a lost project, but however we tried hard, and again in 2022 we are about to launch this Chandrayaan 3. So in this respect, it is important for us to understand the basics of this Chandrayaan mission. Why is it important? What is Chandrayaan 3? Because it is a continuity of Chandrayaan 2, as it was a failure or not success, I would say. Now, on which part it is landing? If it is landing on South Pole, then why it is landing on South Pole? Why not on North Pole? So in this arena, or in this entire paradigm, we have to look at this topic, because questions might be asked from you in your interview section, specifically about the poles of the moon. So the Chandrayaan 3 mission, let's just take some peculiar information that might be PT specific. So the Chandrayaan 3 mission is a follow-up of Chandrayaan 2 of July 2019, which aimed to land at a rover on the lunar south pole. Important. So the Chandrayaan has nothing to do with the North Pole. Why it has nothing to do with, or all the missions, why they do not have anything much to do with the North Pole, we will be seeing later in this video, right? Chandrayaan 2 was sent aboard the country's most powerful geosynchronous launch vehicle, the GSLV Mk3, means GSLV Mark 3. So geosynchronous and geostationary, we have two satellites. So geosynchronous and geostationary. Stationary remains fixed to the point where it was placed, right? So hence we see only one part of the satellite, and we feel that it is rotating along with the Earth axis, right? Because it is fixed as one place, hence it is known as geostationary. Whereas the synchronous means that it is aligned in one channel, and there it is actually making a movement, right? So this is called as geosynchronous. So stationary, let's suppose it is fixed here, so it will rotate along with this point only, right? But synchronous is getting the data by making a rotation around the object where it was sent to. So this is a basic difference. The lander Vikram, instead of controlled landing, ended up a crash landing and prevented rover Pragyan from successfully traveling on the surface of the moon. What happens is, the more thing will be cleared here. In Chandrayaan 2, the configuration was of three components. Number one was rover, number two was orbiter craft, and the lander craft. These two, that is the lander craft and rover, got crashed. However, we got lucky enough that this orbiter craft actually kept on moving the South Pole, and hence we actually have been able to collect very much peculiar and critical data from the South Pole configuration of the moon side. So orbiter we are not sending in Chandrayaan 2, whereas rover and lander craft will be sent in Chandrayaan 3 mission, because orbiter from the Chandrayaan 2 mission is still there, so there is no need to spend money, use resources, and send this component, as it is already installed there as planned. This is the basic difference here, right? Now, so had the mission been successful, it would have been the first time a country landed its rover on the moon in its maiden attempt. So India actually could have made history in the world arena, but no problem. Chandrayaan 2 mission was India's first attempt to make a soft landing of a rover on the uncharted south pole of the lunar surface. And Chandrayaan 3 will be a mission repeat of Chandrayaan 2 and will include a lander and rover similar to that of Chandrayaan 2. So it will be lander and rover that will be sent in this Chandrayaan 3 mission, whereas the orbiter is still there as it was placed under Chandrayaan 2, but will not have an orbiter as the one deployed by Chandrayaan 2 is working just fine. So as I said, the rover and craft will be sent, but the orbiter is still there as it was the component of Chandrayaan 2 mission, right? So ISRO is planning to land the Chandrayaan 3 lander at the same location as the Chandrayaan 2, the lunar south pole. So there is no change here, right? So in a nutshell, if we just explain, or if we know the information about this Chandrayaan 3 mission, what is it? That the Chandrayaan 3 is a successor to the Chandrayaan 2 mission, simply, right? Just a second, guys. So, and it will likely attempt another soft landing on the lunar surface. This is what we have seen so far. And as it is a mission repeat of Chandrayaan 2, but it will only include the lander and the rover, whereas the orbiter from the Chandrayaan 2, that is the previous mission in 2019, is still working fine. So we are not sending it now, right? These are your PT specific points. As per ISRO, the total cost which is going to be involved in this Chandrayaan 3 mission will be somewhere over 600 crore rupees in comparison to the total cost that was incurred during the Chandrayaan 2 mission. It was 960 crore rupees, right? So because orbiter is missing in this mission, so thereby we have this reduced cost incurred in this mission. Now, if you are asked a question that India is a progressive country, it is a poor country. Here, are we are spending this much amount on the space mission, whereas this much money could have been used in so many other things like agriculture, because many kisans are doing are attempting suicides in mostly Vidarbha region or other vulnerable areas in the country. We have so much of poor to feed. We have very poor and vulnerable health infrastructure. So this money could have been invested in this section. If someone asks you this question or in this context, you cannot deny that investment in science and technology programs, components, or research and development aspects, it is not required, because it is very much required for countries like India, for third world countries like Bangladesh, let's say Pakistan, African countries. Why? Because these countries are also struggling with the disaster issues, drought issues, changing pattern of environment issues, thanks to the contributors of industrial revolution world, those who are not ready to take the front step responsibilities of spoiling the environment, and countries like India where resources are limited and they have to be spent wisely, still they are taking care of the environment. In this matter, science and technology is working as the driver which will lead the country, which will lead the society, because we can make the things accessible in faster and more efficient ways, and that can be used and utilized for those sections where we are requiring growth, where we are expecting more results, robust results at faster pace. So in this manner, investment in science and technology is as important as feeding the poor people and bringing skills to them for their livelihood. So we cannot put one at the stake of others, right? So that could be, or somehow it could be your answer, right? Now, here, so if we have seen that this Chandrayaan 3, it is a mission repeat of Chandrayaan 2. So in this manner, we should know that what is mission Chandrayaan 2, right? The mission brought together an orbiter, lander and rover with the goal of exploring the south poles of the moon, south pole of the moon. It aimed at studying not just one area of the moon, but all the areas combining the exosphere the surface as well as the subsurface of the moon in a single mission. So this mission's objective is very much important. Right now, here there are so many questions coming up, like that why are we so interested in studying the moon, what it will tell us. So in a nutshell, if we say the moon is the closest cosmic body at which space discovery can be attempted and documented, simply because it is not very far from Earth. It is somewhere about 3.5 and 3.6 lakh kilometers from the Earth's surface. So we can easily go there, make researches, gather information. We can easily send our mission components, equipments there, infrastructure we can send there, and that can be studied well, and that transmission of data is more secured rather than sending to the far-flung bodies like Venus, Mars, or other areas, right? Because we have to wait for so long period, and that information could have been easily converted into many other products or many other researches as an outcome, right? So it is a closest cosmic body in which the space related missions can be attempted to gather the space discovery information and other related data. First thing. Second, it is promising test bed to demonstrate technologies required for deep space missions, right? Because if we are sending our missions to the far-flung areas like, let's say, Mars, so almost it took for us 10 to 11 months to send our Mars mission equipment, satellites, and we had to wait for so many things, and in between the distance we had to face so much of suspicion that whether the mission was lost, as you might have watched this movie Mangalyaan or the mission Mangal. So in this way you have seen that this suspicion, this fear of getting the satellite dumped, crashed, lost signals, and so many things, and these missions are very expensive in nature. Therefore it is working as a test bed for our deep space missions, right? So it's like a testing ground. The moon provides the best linkage to the Earth's early history, right? Because the ice deposits, the craters, the water shields on the moon, so that can actually tells us that what has happened before this solar system came into existence, right? So much of information actually we can be gathering from the moon as a cosmic body. It offers an undisturbed historical record of the inner solar system environment, as I said. So this is how these 2, 3, 4 important points you should always keep in mind while making a rational attempt to answer that why are we so interested in studying the moon in the outer universe or in the outer space. Right now, the next question could be here that why are we so interested in studying the South Pole for the moment. Let me just show you something that, for example, this is the Earth tilt, and as you can see that if this is perpendicular to the ecliptic, so that means equator would have been here had the Earth not have any kind of tilt, but Earth has this right tilt by the 23.4 degree north. So this, from the imaginary straight line to the tilt, this angle is known as obliquity, right? So obliquity is nothing but just the angle of inclination of the body from its imaginary straight axis, right? This obliquity is 23.4 degree in case of Earth, whereas in case of moon it is not more than 1.5 degree north, right? So it is also a tilted body. Here if you see that if the Earth tilt is this much, so that means that somewhere here and almost somewhere here the Earth will have the sunlight of the moon, sunlight from the sun on the surface, because if the tilt is there, then the scope of light spreading over the poles or the Arctic region or subarctic region, it is still possible. Whereas had Earth been so straight with no tilts towards the north or at any angle of obliquity, so the Earth would only get this half portion would only get the light whenever the rotation part brings the half of the Earth to the moon or to the sun, facing the sun. So in this manner we can say that this half portion is getting sunlight if Earth is straight on the imaginary axis in the straight line, whereas now it is in the obliquity function. So this tilted position Here also it will get some light. Here it will get some light. So therefore the shadowy part remaining on Earth is not that more or voluminous, whereas in the case of moon, because moon, imagine that this white line, this white dotted line, it is the real axis of the moon. So in this manner, the moon is a straight heavenly body which is divided into two halves, and at one time only the half side of the moon gets the light from the sun. The other half remains the similar, because the sunlight is not reaching to that region. In this manner, the south pole of the sun is more shadowy. South pole of the sun is more shadowy because of the shadow from the larger body, let's say Earth, and the angle systems in that way, because it is not getting that much of light, because 1.5 degree north tilt of the moon is making the south pole as the more darker and more shadowy. Hence there are many craters present on the south pole which has not received the sunlight for more than 2 billion years. So right, it is more icy, more snowy, and here the water is actually iced and freeze in very high volumes, right? So the point I just want to discuss with you is that why are we so much interested in studying the south pole? Why did the ISRO choose the moon south pole as the landing site for Chandrayaan 2? Important for your interview part, right? And you should know this. So let's just read about this. The lunar south pole is one of the most compelling places in the entire solar system, because the towering massif, that means the peaks of the south pole, that is Aitken basin, can be accessed, and these massifs contain impact melt that will allow scientists to unambiguously determine the age of this huge basin and could provide insights into planetary formation. Planetary formations means the solar system. Because of this melt or impact melt which is there on the massifs of South Pole Aitken Basin. Permanently shadowed craters may harbor reservoirs of ices and other volatile compounds that could serve as a tremendously valuable resources for future explorers, because it's like a natural freezer or a cold storage on the South Pole that has actually preserved many volatile compounds that would have been present on the moon since the time of its formation. So that is why, due to this darkness, the ice has actually kept so much as hidden treasure in its harbors or in its craters or so many places that information could be highly important for this generation and also the future generation for the valuable discourse of information. Right now, these volatile deposits could contain a priceless record of water composition dating back to the beginning of solar system, an incomparable data set for astrobiology investigations. Important point to be quoted in your interview part. A few mountain peaks near the pole are illuminated for extended periods of time, which could provide near constant solar power for a permanent lunar outpost sometimes in the far future. In addition, South Pole region has craters that are cold traps and contain a fossil record of the early solar system. We are not sure yet that whether moon has any life or not. We do not understand this concept of, and hence we call it as an alien thing. Alien means that is not belonging to us and that is not understood by us. So that is known as alien. So it's not like alien or like Jadoo from Koi Mil Gaya. It is really about alien that we do not understand. So this fossil record, if there had been any sort of life, if there had been any sort of flora and fauna, so if it is there, so if we are lucky enough, then this cold traps of South Pole could be or could have been working as a great natural freezer, which would have stored important information for us in the form of fossil fuels. So if we are lucky enough to discover those, so we can get or collect so much of information for the formation of or about the formation of solar system or other progressive functions, right? Now, if we have to know that why the NASA has, or India's ISRO has chosen the South Pole, then it is also important that why India did not choose the North Pole, right? So why not North Pole again? The South Pole of the Moon has a large shadowy region, larger than that in the North Pole. It contains places that remain in permanent darkness of where sunlight never reaches. As I have explained, that the Moon has this obliquity of just 1.5 degree north, right? So here in this manner, this part is getting more sunlight, but here the South Pole is not getting that much of sunlight, hence it is more shadowy in nature. So right, so remember this 1.5 degree north obliquity. The word here to be remembered is obliquity. So Earth obliquity is 23.4 degree north, right? The South Pole is at the edge of the Aitken Basin, the largest impact basin in the solar system, and NASA's lunar reconnaissance orbiter is still flying over the South Pole region at an altitude of only 30 kilometers, collecting a wealth of data. Unlike Earth, which turns on its axis every 24 hours, the Moon takes about 30 days to make a complete rotation. This means that days and nights on the Moon's last 2 weeks. Hence, it is important that the duration we get for exploring a continuous set as day and night is long enough, right? So we are actually choosing the Moon. This is also an important reason here. So we have chosen the South Pole but not the North Pole because of the shadowy region or shadowy part thing, and hence where the more shadow part is there, so more ice landing part is there, hence the scope of discovering more information in the form of preserved study, that is large enough on the Moon's solar south solar side, right? So in this context, we have to just look at this, and if you want, then you can actually just make a read about this Gaganyaan, the Aditya L1 satellite, and this X-ray polarimeter satellite. So this is just for your information while you are collecting the information about the universe and other cosmic bodies. So this is about the Chandrayaan-1 mission. We have seen that why it is important. What about the South Pole landing? Why not North Pole landing? What is the reason we have seen, and what was sent there in the Chandrayaan-2, and what is missing in Chandrayaan-3? Only the orbiter is missing, and we have already collected so much of information from the orbiter help, whereas we also require to have under Chandrayaan-3 the rover and the lander landed on the South Pole region at the Aitken Basin, so that we can actually explore more discoveries and exploration in the region for this generation and for the future generation to come on, right? So that was about the Chandrayaan-1 or Chandrayaan-3 mission with respect to the Chandrayaan-2 mission. Thank you so much.